binomial expansion. By María José Gómez. In this video, I am going to explain the mind map on binomial expansion. We can see it is divided in 1, 2, 3, 4, 5, 6, 7, 8 sections, in which we are going to talk about the different parts of the binomial expansion. First, let's talk about the expansion type, and then about the coefficients and the Pascal triangles relation. So firstly, the expansion type is a plus b to the power of n, on which there are always two terms and they are always multiplied and expanded into something, and that something is represented by the n letter. Then we have the coefficient and the Pascal's triangle relationship. Each expansion and each term has a different coefficient depending on the level it is placed on. If the expression is to the power of 3, then you will need to see the number 3 level to identify which are the coefficients of the expansion. In this case, it will be 1, 2, and 3. So, how is this related to this theorem? Well, the Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So it's the addition of the two numbers upwards. It will give you the one in the middle. In this case, 1 and 2 will give you 3. 2 and 1 will give you 3, and it always starts and ends with a 1. This is related with this as the coefficients theory. It says that 1 is equal to 0, choose 0. When you have 0, choose 0 is equal to 1. When you have 1, choose 0, it will be 1, and then you will have 1, 1. Do you see the pattern? So you start with the level, that would be 0, and how many times it's chosen, so 0 times. Then, for example, in the level 2, it will be 2 because of the level, and chosen 0 times, chose 1 time, and chose 2 times. So now let's continue with the NCR. The NCR is the way to express the coefficients of this theorem. So firstly, how you read it. When you have NCR, you will say N choose R. This means to choose R of objects of N. For example, if you have 10 squares and you have to choose 2, how many 10 of 2 can you make? So, N choose R. Then, how to write it? In another way to write it, you could say that NCR1 for the term 1, NCR2 for the term 2, NCR3 for the term 3. So, what's the meaning of C? C is the selection. How many options do you have of making that pair? So now, let's talk about the formula. The formula is really easy. It's n factorial divided by r factorial times n minus r factorial. So then, when you add r plus this number, it will give you n. So then you'll have n factorial over n r factorial minus times n r factorial. Now, there is another way to write this, and it's the same. NCR is equal to NC times n minus r. Why is this equal? So, let's see here. When you have this combination, you could see that it's n factorial over r factorial minus times n minus r factorial. So why would we say that they are equal? The other one, the expression of nc to the n minus r will be equal to n factorial divided by n minus r factorial times n minus r close brackets factorial. And when we simplify this, it will be n factorial divided by n minus r factorial times n minus n plus r factorial. When you take this and simplify it, it will be n divided by n, it will be n factorial over n minus r factorial r, which will be the same of the first, in the first rule, n factorial over r factorial times n minus r factorial. So now let's talk about the values. When we have nc0, that will be always 1. This is our rule. It's always gonna be 1. In the other hand, when we have, let's erase this. On the other hand, when we have nc1, it's always the answer, it's gonna be n. So when you have it to the 1, the answer will be n. Now let's continue with NPR, where P means permuted and NPR is always the arrangement. The formula for this is NPR equals to n factorial over n minus r factorial. What this means? This means how many ways you can combine something. So, for example, if we have 10 blocks and we want to see how many times we can arrange 5 of them, making different pairs, we will have to use this formula instead of the last one. The last one, the NCR, was about the selection. So how many possible ways? This is how many possible ways of selecting each other without repeating. So it's the arrangement. They're really different concepts. Let's continue with the terms. Firstly, how do you know what is a term? Terms are always separated by r plus or minus. So, number of terms is in an expansion. Let's say that we have the following expansion: a plus b to the power of 3. Using this as an example, we know that n would be equal to 3. So n plus 1 will be equal 4, according to this formula. So after we expand this formula, this expression, we will have 4 terms at the end of the expansion. So n here would be the exponent, and will be always this number. And let's use another example to understand. N plus 1. Like we don't have any power, I will say it's to the power of 1, so 1 plus 1 would be 2. So after expanding this, you will have 2 terms. Now let's talk about the formula. The formula to find the number of terms is dr n r minus 1. Here, most of the people would say this is a fraction, but it's not. It is a way of writing CRN, of choosing, which is completely different. After that, we know that x would be r minus 1 and y would be n minus times r minus 1. But there is a variation that makes everything more simple. Actually, there are two variations, and they are made because they are easy to remember and they are most easy to remember. And they are easier to simplify and to use. So it will be tr plus 1 equals nr x on n minus r y r. And also you can play with the arrangement of these. It could also be nr x to the power of r and y into the power of r minus n, of n minus r, sorry. So why can we make this variation in the exponents? Because the order doesn't matter and the answer is always going to be the same. So to calculate this, if you don't have much time to do the n factorial over r factorial minus n minus r factorial, you can use the calculator because it has an option to do this type of questions. To do this, first you'll have to math the standard, and then you'll need to press the option button and then the probability button, which is in the second page of those options, and then you will have an option that says NCR, and that's a really easy way of doing it. So now let's use some examples. What would be another way of writing minus 5 to the power of r? It will be minus 1r 2 and times 5 to the power of r. Another example would be minus 6 to the power of n minus r, that we could also write it as minus 1 to the power of n minus r times 6 to the power of r. So now let's do a harder question. What is the coefficient of x cubed in 2x minus 1 over 3 to the power of 2 and that whole expression to the power of 8? So let's do this. For this, we're going to use the formula of tr plus 1 and we are going to replace the values. So we already know the value of n, which is 8, and we are going to write all the values we have but completing them with the expansion. So we know that the formula says tr plus 1 is equal to nr over times x r y and minus r. So we're going to replace those values. We know that x here has a coefficient of 2, and to make calculations more easy, we're going to divide it. And then we know that y will be this whole fraction, that we're going to simplify it by putting this 3 to the n minus power and this x to the minus power. So then let's simplify n plus r. And now we will have that x will be r and minus 16 plus 2r after we do the expansion. And now we're going to say that minus 16 plus 3r is equal to 3 because in the question they say that we need the x to the 3 term. So we are going to do this equation. And now we know that 3r is equal to 19 after passing this 16 to this here, but as an addition. And then we know that r will be 19 over 3. But that doesn't make sense because there are no half terms. So we're going to say that this is an 18. So we could say that r is equal to 6, a real term. So now we move to the other side. And let's say, and just replace the r value. So T7, it will be 8, 6, 2, 6, minus 8, minus 6, that will be 2. And you have to take care here. It will be x3 because you did this process. So now you can replace x with x3 because you know that value. And then in your calculator with the option and then probability, you will know that this is equal to 28. 2 to the power of 6 is 64, minus 3 to the power of 2 will be 9, and x to the power of 3. So then you multiply these values and they will give you this number, and it is x3. So this will be your answer. 120 will be your coefficient in the term 7 for the x cube. So now that we know that a binomial expansion would be like this, because it has two terms, a trinomial expansion would have three terms. Therefore, an example of a trinomial expansion could be x times plus y plus z to the power of n, because we have three different terms.